Tiny drones are becoming more capable every year, but one of their biggest challenges is navigating in places where cameras simply can't see. Thick fog, smoke, heavy snow, or complete darkness can leave even the smartest flying robots struggling to avoid obstacles. Now, researchers have developed a fascinating solution by taking inspiration from one of nature's best navigators, bats. The new drone system is called Saranga, and instead of relying on cameras or lasers, it uses sound to find its way. Just like bats flying through dark caves, the drone sends out high-frequency sound waves and listens for the echoes bouncing back from nearby objects. That allows it to detect poles, tree trunks, transparent plastic sheets, and other obstacles, even when visibility is almost zero. Traditional cameras and LiDAR sensors work well in clear conditions, but they lose accuracy when light is scattered by fog, smoke, or snow. Radar can help, but it consumes much more power, which is a major drawback for small drones with limited battery life. Ultrasound offers a much more efficient alternative because sound waves travel through these challenging environments with very little trouble, all while using only a tiny amount of energy. To make this work, the research team built a compact quadcopter measuring just 16 centimeters across. It weighs about 460 grams and carries 2 miniature ultrasound sensors at the front, each equipped with a wide sound horn. A third sensor points downward to monitor altitude. The entire sensing system runs on a small Google Coral mini computer and consumes only about 1.2 milliwatts of power. Even more impressive, it doesn't need GPS or external tracking systems to navigate. One of the biggest technical challenges turned out to be the drone's own propellers. As they spin, they generate a lot of ultrasonic noise that overwhelms the weak echoes returning from distant objects. The researchers came up with a surprisingly simple fix by placing a lightweight shield made from foam and plastic between the propellers and the sensors. This barrier blocks much of the unwanted propeller noise, while still allowing outgoing sound waves and returning echoes to pass through. That simple improvement doubled the drone's effective detection range from about 1 meter to roughly 2 meters. Even with the shield in place, the returning echoes still contained plenty of background noise. Standard filtering techniques couldn't reliably separate real obstacle reflections from interference. So the researchers turned to artificial intelligence. They trained a compact neural network, also named Saranga, to recognize the unique patterns created by genuine echoes while ignoring unwanted noise. The AI was trained using a combination of simulated data and recordings that included real propeller noise. Once training was complete, it performed remarkably well in real-world testing without requiring additional adjustments. The neural network is small enough to run directly on the drone's Edge TPU accelerator, using only about half a gigabyte of memory. Each analysis takes around 15 milliseconds, while consuming only a few millijoules of energy, making it fast enough for real-time flight. After the AI cleans up the sound data, the drone determines where obstacles are located. Because the 2 front sensors are mounted at slightly different angles, the system can calculate the direction of nearby objects much like a bat does with its ears. The downward-facing sensor continuously measures height, giving the drone a complete understanding of its surroundings. From there, the flight controller simply receives a constantly updated map of nearby obstacles and adjusts the drone's path to avoid collisions while continuing toward its destination. It's a remarkably elegant system that combines simple hardware with efficient AI to achieve reliable navigation in conditions where traditional vision systems struggle. This technology could open the door to drones that can safely operate during wildfires, search and rescue missions, industrial inspections, underground exploration, and disaster response, where smoke, dust, darkness, or severe weather often make camera-based navigation nearly impossible. By borrowing a strategy perfected by bats over millions of years, researchers have shown that sometimes the smartest innovations come from nature itself.